Solve problems with similar shapes. The following shapes are similar. Is it true? Well, circles are always going to be similar. Which of the following three shapes are similar? Of these three shapes, to be similar, we would have to multiply that side by 2 to get 2, and then this one by 2 to get 4. So it's got to be A and C. Well, just to prove this to you, if we multiply 1 by 2 to get 2, we'd also have to multiply this one by 2 as well to get 4, but it's actually 3, so it's not B at all. So A and C. Two squares must be similar. Well, yes, they absolutely do. The following shapes are similar. Scale factor from A to B. So what we've got, just got to look at which side we can look at and compare. Well, the easiest one would be the 5 and the 2 here. So the scale factor going from A to B is multiplying by 5 over 2, which is 2.5. The way you do it is you've got firstly the final number 5 over the initial number 2. You're using the two corresponding sides there. Now you can see they're actually reflections of each other, so they do correspond. So from this one to this one we've got times 5 divided by 2, which is 2.5. Over here, scale factor enlargement from A to B, we've got this 20, which corresponds, if we reflect along this line here, the 20 corresponds to the 30. So we're going from 20 to 30 is times 1.5. Man's garden is in the shape of a 4 metre by 8 metre rectangle. In the centre is a rectangular flower bed measuring 1 metre by 2 metres. Are these two rectangles similar? Well, we can look at this from 1 to 4, we're multiplying by 4, and from 2 to 8 we are also multiplying by 4, so they are similar. These two triangles are similar, so we've got this little triangle here and this big triangle over here, which are similar. Now what that means is that it's just an enlargement. Just make the smaller one larger and it will, all of the sides will match on here. You may need to rotate it or reflect it, but anyway, the point of this here is we're going from the small one to the larger one, to ABC, which is a larger one. And what would happen is 6 is the medium side and 12 is the medium side as well of a larger triangle. So we're going from 6 to 12, multiply by 2 to get there. Which of these shapes are similar? Let's just look at the angles, because often you can just look at the angles and see. So we've got 55 here. This one's got 50, and that one's also got a right angle here. There's 90, yep, okay, so it looks like this one here, 50 and 50, and this one here as well, 40, because then you have 50 over here and 90 to make 180 as well. So for your 50, 40 ones, except for this 55 and D, so we've got A, B and C. Okay, A, B, C and C, D, E are similar. Length of AB is 16 meters. So what we're doing is we're going from 16, and the matching one, if we rotate this around and make it smaller, 16 corresponds to 8. We're going to go over here and you've got to divide by 2. And so if we try to find length of CD, which corresponds to the 24, we've also got to divide by 2, which is 12. Which of the following triangles are similar? 45 here. When you've got a right angled triangle, the other two angles have to add up to 90, so this would be 45 as well to make 90. It certainly doesn't match this 39 over here. Neither does it match this 30 over here. Well, it looks like this one's because A and D are going to match. They've both got 45 each, so that's that. Alright, so that's it.